So you're going to find in Chapter 3 we do a lot of stuff similar to what you learned in Chapter 2 is solving equations, except that we're going to be dealing with inequalities. So today's lesson is going to focus on graphing inequalities and also evaluating inequalities, trying to find out if solutions are true to inequalities, which will be really important for checking your answers as we begin solving them. So the first example asks you to identify solutions. And it just says, is each number a solution of x is less than or equal to 7? So quick review, just in case you forgot. Greater than or equal to. So that's the greater than or equal to sign. Less than or equal to. Just in case you forgot which way they point. And then the numbers that they give you are 9, and 14 over 2. So you're just going to check these. You can check them mentally eventually, but for notes and for your work, just to show me you understand what you're doing there, go ahead and plug them in here. So you're plugging in 9 for x. 9 is less than or equal to 7. And you have to stop and think, is 9 less than or equal to 7? And you're going to say, no, it's not. So that is not a solution. Then you can try 14 over 2, and 14 over 2 actually simplifies, and it ends up equaling 7. So if you plugged 7 in, is 7 less than or equal to 7? Because it's or equal to, it is, so this is true. Or you could say yes. And that's all you're doing on those. And once you get really good at that, that's going to help you with checking your solutions. Okay, example 2 is identifying a solution by evaluating an inequality that has more than just x to something. So I'll show you that one. Is each number a solution of 2 subtracting 5x is greater than 13. So over here this is evaluating. And there's not much to write on the left because you all are pretty good at evaluating by now. So just remember parentheses around what you are plugging in. And then instead of looking for it to balance, you're just looking for it to see if it's true or not. So the first one they give you is 3. So you're just going to write your inequality with a 3 in for x. So 2 subtracting 5 times 3 is greater than 13. Order of operations tells you to multiply before you subtract. So 2 minus 15 is greater than 13. 2 subtracting 15. Hopefully you all notice these are opposite signs, so the difference is 13. 15 was larger. So negative 13 is greater than 13. And is a negative 13 greater than 13? Hopefully you all noticed it's not. So this is not a solution. Alright, let's try another one. Try negative 4. Two subtracting 5 times the negative 4 is greater than 13. Okay, I noticed in chapter 2, every once in a while, right here when you were multiplying, you got negative 5 times negative 4, positive 20. So then you were saying 2 times 20. It's not. This is a subtraction right there. So it's 2 minus whatever that is, 2 minus negative 20, but two negatives there become positive. So it's actually 2 plus 20 is greater than 13. And 2 plus 20 is 22. And 22 is greater than 13. So negative 4 is a solution. So it is a solution. And it's going to be important to realize that you have to think about the fact that there are so many numbers out there that can be true, because it just has to be greater than 13 once you plug it in. Where when we were looking at equations, there was typically only one that could be true. But in the inequalities, you're going to have tons of options, and that's going to lead us into our next examples. Now we're going to talk about graphing these inequalities. The rules that you're going to learn for graphing these inequalities are pretty important all year long. So you'll probably remember this from last year, but I'm going to review it. There's something called an open dot, which means it's not shaded. And then there's something called a closed dot, which means it is shaded. And we're going to go back to that in a minute. So this is example 3. Graph C is greater than negative 2. So kind of think about examples 1 and 2 here. You could come up with so many numbers that you could fit in for C. Think about some different numbers you could fit in. You could put in something like 0. 0 is greater than negative 2. You could put in negative 1. You could put in negative 1.5. You could put in 1 million. You could put in negative 0.263. Lots of different numbers that are all going to be greater than negative 2. And you could spend the rest of today, tomorrow, the whole week going through and writing down all the different possible solutions there. It goes on forever one way. So instead of having to do that, we're going to take a shortcut, and that shortcut is learning how to graph these on a number line. I know there are several different ways teachers have you graph these, so I really want you to try graphing it the way that I'm asking you to do it for this year. And the first thing is I always want arrows at the end of your line here, showing that it keeps going on. This is a great time to have a highlighter. The next thing that I always want is I always want dashes going through, and I want at least every other dash labeled. So I know I need something with negative 2 about at the middle. I usually put this number somewhere toward the middle of my graph. I'm going to go ahead and put negative 2 right there. Negative 1, 0, 1, 2, 3, 4, negative 3, negative 4. So you can label every other if you want. Once you have this set up, you always start at whatever this number is right here. So your dot starts there. And you need to determine if it's an open or a closed dot. And the way that you do that is you think about, this is not going to be part of the answer. Negative 2 isn't part of my solution. If it was or equal to, then negative 2 would be one of my solutions. but this is just my starting place. And then all of my solutions either go up from there or down from there, depending on this sign. So that makes it an open dot. It's not shaded because it's not part of your answers. So any greater than or less than signs are always an open dot. Where if it was or equal to, it would be a closed dot. It would be shaded. It would be part of your answers. So these are the less than or equal to and the greater than or equal to's. So when you go to graph these, you're going to put either an open or a closed dot at the number you're starting on. So I'm starting on -2. It's not an or equal to, so it's an open dot. So I put an open dot right on -2. And I know a lot of you have had teachers in the past who have you put it above. I also know a lot of you have had teachers make it really small, which I completely understand because right now this dot is kind of showing all those other numbers in between there also. But I need it to be large enough so I can tell that you left it open, that you didn't shade it. And then this is where a highlighter is great for this chapter because it makes it a lot faster for you and it makes it a lot easier to see your graph. Now what you're going to do, and I want you to try it this way, even though I know a lot of you have a shortcut and you have some other things, but I just want you to pick a number on the right of that or to the left of that. Doesn't matter because this is going to help you later when these are more difficult. So pick a number like -4. Is -4 greater than -2? And no, it's not. Is 0 greater than -2? Yes, it is. So I try a number out. Is 0 greater than -2? Yes. When I get yes, then that's my shaded side. Everything on that side is true. So from this dot over and including my arrow because it's ongoing, that is all of the shaded part of that graph. And these are all possible solutions. So let's write a little bit about that over on the left here. When you go to graph it, you're going to need an open or closed dot. You're always going to isolate the variable, which in this case it was. Tomorrow we're going to start when it's not. Then you're going to start with a dot on the given number, on the side that doesn't have the variable. Then you're going to evaluate with a value above or below that number on the number line. Like we did with 0 over here. And then the true side is the shaded side. So you always shade possible answers, which is why we use a closed dot when it's or equal to, because it's shaded. It's part of the shaded answers. Open dot when it's not or equal to, because it's not part of the shaded answers. So go ahead and hit pause, finish writing that, otherwise I'm going to move it and start explaining more. Now I want to go over one more thing here that's really important. I know a lot of you have learned a shortcut here that it's the variable and then whatever way the arrow is pointing is the way that you end up shading. This is a great shortcut if you understand the whole rule, but you have to make sure you understand the whole rule. And the rule is that only works when the variable's on the left and the number's on the right. If this had been written the opposite way, where -2 was over here and C was over here, that rule would no longer work. It would be the exact opposite. So don't use that rule unless you completely understand how it works and if you understand how to switch that back around when it's not that way. So I'll show you an example of that right now, just so you see it. Example 2, M, this, or not a 2, sorry, but the next example of this is less than or equal to 4. So we draw our number line. And we need 4 somewhere in the middle, so 4, 6, 8, 2, 0. Now you're going to do the same thing. Start at the number they gave you. So we're starting at 4. It's an or equal to, so it's a shaded dot. So I put a dot at 4 and I close it in. That's a shaded dot. Now I'm going to go pick a value that I think is going to work. Something like maybe, I know less than 4, probably 2. So let's try it. Is 2 less than or equal to 4? Yes, it is. And since it is, and I know this side of that dot is my true side. So I grab my highlighter and I highlight that side. Or if you don't have a highlighter, what I want you to do is I want you to just go across with your pencil and just kind of darken it like that, and make sure you darken the arrow also. So I want it to be pretty obvious that you're going all the way to the other end, including the arrow. It's everything and past. Now we're going to look at that exact same problem. So notice the arrow's pointing that way, but I just want you to see the difference with that exact same thing if it had been written like this. 4 is less than or equal to m. So those look almost exactly the same. Go ahead and draw your number line. So I'm going to start at 4 here again. 6, 8, 2, and 0. And again, we're starting at the number. So we're starting at 4. It's an or equal to, so I'm going to do a closed dot, shaded dot. But now let's try that 2 again and see what happens. Is 4 less than or equal to 2? No, it's not. So in this case, this 2 I plugged in does not work. So this is my no side. This becomes my yes side. Notice the arrow's pointing the wrong way. So that arrow trick doesn't always work. You have to be careful when your variable's on the right. If this is no, you know that's yes. You don't have to take another turn. You can try it if you want. Is 4 less than or equal to 6? Yes. Is 4 less than or equal to 8? Yes. The next example is a reverse of what we were just doing. This is writing an inequality when you're given a graph. So example 4, write an inequality for the given graph. And here's the graph. I'm going to give you one. This is your first one. So this is the graph you're given. You need to write an inequality based on it. You're going to work the exact opposite way that you graphed these. So you know that you have a variable on the left and a number on the right. That's the way I would start every time. So you pick the variable unless they tell you what to use. So I'm going to go ahead and use x, since this is really representing like our x-axis anyway. So I've got x on the right, or on the left, and then you put the number that has the dot on it on the right. So -4. Now you have to think about plugging one of these values in and determining which sign would work. So plug in something like -6. Is -6 greater than -4, or is -6 less than -4? And hopefully everyone came up with less than. So you put your less than sign. Now you go check your dot. Do I need or equal to, or do I leave it the way it is? And you should have left it as or equal to. So that's how you're going to set each of those up. So let's go write that on the left. And then I'm going to write a few, have you pause it and try them, and then check them as we go. So your steps for this, for writing an inequality from a graph, are variable on the left, number the dot is on the right. Then from there, plug in one of the shaded, the true solutions to see if it's greater than or less than. So you're going to plug in one of those shaded true solutions and see which sign inequality you're going to use here. Then you're going to look at the dot to determine if you need to add the or equal to line. Always remember that. So hit pause now, finish writing that, and then I'm going to write out the first one and go ahead and try it, and then unpause it as soon as you're done with each of them. We're going to do 3 more, so you're going to try 3 of them on your own. Here we go. So you always want to start with the same pattern that we just talked about over here. Variable on the left, number the dots on the right. So x is something to 5. Pick a number that's in here in the shaded area, like 3. Is 3 greater than 5, or is 3 less than 5? 3 is less than 5. Now I go look at my dot. Do I need to put or equal to? And because it's closed, shaded, I do. Alright, let's try another one. Again, write this down after I do, then hit pause and try it. Once you have one, watch mine and make sure you're right. Okay, this one's a little tricky, so be careful. Alright, hit pause. Hopefully you put the variable on the left, and then you went to the dot and found the number. Notice the number is between 0 and 1, and you all know between 0 and 1 is 1/2. So this is 1/2. You can have fractions there. All this space in between here is it's all your fractions and your decimals. You're just going to have to estimate the best you can when they're not labeled like that, but typically it's going to be a number like 1/2 or 1/4. You'll kind of have a feel for it. Now you hopefully plugged in a number that was in this shaded area, like 2. Is 2 greater than 1/2 or is 2 less than 1/2? And it's greater than, so I'd put a greater than sign in. It's an open dot, so I leave it the way it is. All right, one more. So hit pause, try to write your own, and then hit play when you're ready. Alright, so same pattern. That's a really nice thing about a lot of this algebra stuff is it looks difficult, but if you follow those patterns, then you'll get really good at this stuff. X on the left, number that the dot's on the right. Plug in a number from here, like 2, or 1, or 4, or 3. Is 4 greater than -1 or is 4 less than -1? And hopefully you all said greater than. And now you go look at your dot and it's a closed dot, so I need to add or equal to. And that's how you're going to write an inequality from a graph. Example 5 is actually based on a couple pictures in your book, and the pictures are on page 126. If you want to look at the actual picture. I'm just going to give you the information in the picture. So the first example, it's just asking to write a variable and an inequality for each situation. So it says define a variable and write an inequality for each situation. Remember, when it says define a variable, all they're asking you to do is just pick a variable. You can call it X, you can call it Y, you can call it B, call it whatever you want, but you want to get really good at defining variables that make sense with the situation when you're talking about word problems. It will really help you later. And then write an inequality means you're going to have a greater than or less than, or greater than or equal to, or less than or equal to, not just equals. So now we're writing inequalities instead of equations. And the first example is a speed limit sign. That says maximum speed is 65 miles per hour. You've all seen those on the freeway. So here's what you have to think about with this. You can just put X if you want, or you could think of it as S for speed, M for maximum. For me personally, I would probably use S for speed, because I usually try to find the most important of the words there. So you're going to follow the exact same rule we just did for writing inequalities from graph. Variable on the left, number on the right. Now you have to stop and think about what they're saying. They're saying the maximum speed is 65. We're used to thinking of maximum as being larger, but you have to think about it the other way. Think about plugging in values here. Are you legally allowed to drive 75? Are you legally allowed to drive 80? And those should have been no. So greater than 65 isn't working. Are you legally allowed to drive 55? Yes. So maximum is 65, but any number under it is okay. So these just have to be less than 65. Now you have to ask yourself about the or equal to. Am I allowed to drive 65? And all of you should have said yes. And because I'm allowed to go 65 miles an hour, it is or equal to. Over on the left, we're just going to write the same types of things. Variable on left and number on right, just like we did on the graphing ones. Then does greater than or less than fit? You have to try some of them. And then, can it be equal? So those are kind of the questions you're asking yourself as you go through these. And I'm going to give you a little hint. Every time you see the word maximum, it's always, always, always going to be less than or equal to. The maximum is this. Every time you see the word minimum, that means it's the lowest you can go. So everything has to be higher than that or equal to that. So those are always greater than or equal to, which is kind of opposite thinking. We're used to thinking of maximum as the greater, minimum as the less. But you have to think about maximum in this case means it's the highest it can possibly go. So everything needs to be less than it. Minimum, lowest it can possibly go, everything needs to be larger than it. Alright, let's try another one. So this one says it's a store and it's help wanted. And it says $6.15 an hour. And up. So again, define a variable, put it on the left, put the number on the right. So I'm going to go with H for help. So help wanted at $6.15 an hour and up. Now I have to start thinking, what other numbers would I be allowed to plug in here? Is someone going to see this sign and want $5 an hour? Or are they going to see this sign and want $7 an hour? Because it's and up, they're going to want larger numbers. So this needs to be the lowest it can go. This is all your larger numbers, so all of these need to be greater than that number. So you put a greater than in. Now you ask yourself the last question. Can someone get paid the actual amount that's listed here? And yes, they can, because it's $6.15 an hour and up. So this could be just $6.15 an hour, which is or equal to. There are two other words I want to add to this same idea here that are really kind of tricky sometimes. At most deals with the maximum idea. It's the most it can be. So again, it's at less than or equal to. And then the word at least. You have to think about it the same way. It's the lowest it can go. So everything has to be greater than or equal to it. So even though you see the word least, you're not using a less than sign. So be really careful in those. And that's the end of lesson 3.1.